So, good morning, everyone, and welcome to the class on investment management past year question paper discussion. In this class, we'll focus ourselves while discussing the problems on minimum risk portfolio. So, when we are talking about a minimum risk portfolio, here we are trying to understand a scenario where whenever we are trying to create a portfolio. So with different assets, here I believe I have two assets, asset A and asset B. Suppose if I'm trying to create a portfolio with asset A and asset B. Okay, so depending upon the correlation between the two assets, the risk on the portfolio get varies. So probably it is always preferable that if we have an asset having if we have an asset having -1 coefficient of correlation, then probably your risk would be very less. Then probably your risk would be very less. While if in while in case if the coefficient of correlation is +1, then creating portfolio doesn't make any sense. If we talk about risk and return, here we talk about risk and return. So here we are talking risk and return. So ultimately, what matters here, whenever we are creating a portfolio, more or less the stocks for which you create a portfolio, their coefficient of correlation will be between -1 to +1. So they will not be uh, for them the coefficient of correlation, neither it can be -1 or neither it can be +1. If it +1, if the two stocks which we are bringing themselves in the portfolio creation, if the coefficient of correlation is +1, then there's no logic of picking portfolio. If it -1, then it's very good that we have the portfolio having two stocks having -1 coefficient of correlation. In that, there would be a scenario when the risk will also actually become zero. But in general scenario, whenever we create a portfolio, the risk return trade off, if we are trying to determine between the two stocks, their coefficient of correlation will be between -1 to +1. So under that scenario, if we when we change the weight of one stock with the other stock, with different values of the weight, we get different values of risk, so that you can understand. I can show you with an example. I'll show you with an example. Suppose there's a data which already I have calculated. So if I show you, 1 minute. Yeah, you can see this. So if you can see this, if the two stocks, they have +1 coefficient of correlation, this would be the risk return graph. While if they have, while if they have -1 coefficient of correlation, then there would be a tendency when the risk will become zero, and then it will increase. So the weight at which it becomes zero, the weight when the R value is -1, then this would be the weight under which you get zero variance for the portfolio if the R value is -1. But generally, whenever we talk about a portfolio, but generally whenever we talk about a portfolio, generally their values of their risk differs whenever we change the value of the weight of one and two with respect to one another. So under that scenario, if you don't want to do trial and error method, if you want the direct answer for the weight at which you get the minimum risk, so at what weight of x and y you get the minimum risk. So for that you can directly apply the formula. So the weight at which we get the minimum risk. So weight at which we get the minimum risk, weight at which we get the minimum risk, the weight at which we get the minimum risk if your R is between -1 to +1. So for that, suppose the two stocks are there, X and Y. So the weight of X is equal to the formula weight of X is the variance of Y minus covariance between X and Y divided by the variance of X plus the variance of Y minus minus 2 times of covariance between X and Y. So this is the formula what you can use. So if you use this formula, you get the weight of X at which the risk on the portfolio will be the minimum. Okay, so you will get this value. Now weight of, once you get the weight of X, weight of Y would be nothing but 1 minus weight of X. With that you will get the weight of Y. I hope you are getting this. So this is a formula what you need to use. Some books and all, they use this weight of X is equal to variance of Y minus R of XY into standard deviation of X into standard deviation of Y divide by variance of X plus variance of Y minus 2 times of R of XY into standard deviation of X into standard deviation of Y. So you can use this formula also to get the weight of X and Y. Clear everyone? So you can use this formula also. Both mean same thing. You know the formula that covariance between X and Y. You know the relation that the covariance between X and Y. You know that covariance between X and Y is equal to R of XY into standard deviation of X into standard deviation of Y. I think everyone knows this. So please everyone please write down this formula. We'll use this formula to find the minimum variance portfolio. Everyone please write down this formula. So we'll use the same formula to solve this question. So find the minimum risk portfolio. So I'll use the same formula. So the weight of X. So here, first thing, covariance I have to find. Find the covariance between A and B. So the covariance between A and B is R of A and B into standard deviation of A into standard deviation of B. The covariance between A and B, R of A and B is -1 into standard deviation of A. Standard deviation of A is 15% into standard deviation of B, that is 18%. So you can use this. So you will get the answer 15 into 18. 18 fives are 18 into 50. That is 90, 270. 270. So you will get 270. So this is minus, this is 15 by 10. 15 by 100, this is 15%. This is 18 by 100, that is 270. That is 270. So minus 0.027. Clear everyone? 15 into 18 is same thing, no? 15 into 18, 120, and this is 15, that is 270. You get 270 and then 40. You will get 270, then you have 40. Anyone, any doubt? Done everyone. So I got the covariance. Once I get the covariance, then once I get the covariance, I'll find the other value. So I got the covariance. Once I get the covariance, then I'll find the weight of X. Weight of X is the variance of Y minus the covariance between variance of, so here X. So here if I use A, weight of A is equal to variance of B minus covariance between A and B divide by variance of A plus variance of B minus 2 times of covariance between A and B. So variance of B. So you can find the variance of B. So standard deviation of B is 18%. What is the variance of B? That is a square of 0.18. Do that, square of 0.18, that is 0.0324. That is the variance of B. What is the variance of A? What is the variance of A? Variance of A would be square of 0.15. Variance of A, that would be 0.0225. Okay, everyone. So what is the variance of B? Variance of B is 0.0325. Variance of B is 0.0324 minus of 0.027 divide by variance of X. Variance of X is 0.0225 plus 0.0324 minus 2 times of covariance minus 0.027. Okay, everyone. So this is the weight of A. Weight of A is 0.0324 plus 0.027 divide by 0.0225 plus 0.0324 plus 27 2 is 54. No? 27 2 is 54.054. Anyone, any doubt? Anyone, any doubt? So 0.324 plus 0.027 plus 0.027, that is 0.0594, that is 0.0594 divided by 0.0225 plus 0.0324 plus 0.054, that is 0.1089, that is 0.1089. Correct, right? Point point uh point 0.1089. So this is 0.0594 divided by 0.1089, that is 0.5454. This is the weight of A. So you got the weight of A. You got the weight of A. So I can find the weight of B. Weight of B is 1 minus 0.5454. The weight of B. So the weight of B I'll get is 0.4545. This much you have to do. Now we, according to this scenario what is given to us, according to this scenario which is given to us, so we solve this question. So we got the weight of A, what I should take. The weight of A, what should I take? That should be 0.54. The weight of A, what should I take? Is 0.54, and the weight of B should, what should I consider, is 0.45. So if I take the weight of A as 0.54, and weight of B is 0.45, and then if I construct the risk on a portfolio, then if I calculate the by considering this weight, if I construct the risk on a portfolio, so the risk on a portfolio, that by using the formula called W1 square plus sigma 1 square plus W2 square into sigma 2 square plus 2W1 W2 into covariance between 1 and 2. So if I use the formula, so the risk what I get, the standard deviation what I'll get for on this 0.54 square into sigma 1 square is 0.0225 plus plus 0.4545 square into 0.0324, okay, plus here minus 2w1 0.5454 into 0.4545 into covariance. How much you got? You got covariance is minus 0.027, minus 0.027. So if you use this formula, and if you calculate this value, if you will calculate this value, what you will get, this value, the standard deviation, what you will get, that will be the minimum. So the value whatever you will get, so this would be the minimum. This the value what you will get, this will be the minimum standard deviation. Okay, you take any other weight, you take any other weight and calculate the risk on the portfolio, you more than this only. You will never get lesser than uh, the standard deviation. That's why this is the formula. This formula is derived from complex derivation of mathematics. With the after that only you will get the this minimum variance portfolio by using differentiation and all. We use minima maxima concept, and by using that concept only ultimately we got this formula. So yeah, according to this formula we simply has to put our values in this formula. So with this I'll get the weight of A. Once I get the weight of A, then weight of B would be 1 minus weight of A. So the whatever the weight of A and B you will get, if you put that weight into this formula, the formula of the risk on a portfolio, if you put your weight into this formula, you will get the minimum risk portfolio. Clear everyone? Anyone have any doubt? Okay guys, so we already discussed one problem which came in July 2018. That question was of 2 marks. Now the same question, not same means exactly, not exactly same, data is not same here. The same similar kind of question came in January 2018. Question number 6B, again minimum variance portfolio. The same question is now right now is of 6 marks. Again, you'll use the same formula to get the answer. So the formula what you'll use the formula weight of A is equal to variance of B minus covariance between A and B divided by variance of A plus variance of B minus 2 times of covariance between A and B. Use this formula guys. Once you get the weight of A, once you get the weight of A, find the weight of B. Find the weight of B as 1 minus weight of A. Okay. Use this formula guys. Tell me the minimum variance portfolio. Tell me the answer for this. Same logic. Already we discussed the question. Please do it again. I can find the covariance. I can find the covariance between A and B with the R of A and B is 0.5 into standard deviation of A, that is 25%, into standard deviation of B, that is 28%. 0.5 I can write 1 by 2. Then 25 by 100 I can write 1 by 4, and 28 by 100, let it be 28 by 100. So this is what? This is 7 7 4s are 28. So this is what? 3.5. This is what? 3.5. 3.5 by 100. So means what? 0.035. Okay, everyone. So you got the covariance. You get the covariance. So that is 0.5 into 25, 0.25 into 0.28, 0.035. So you get the covariance. Again, I'm repeating the formula of covariance. What is the formula of covariance between A and B? That is R of AB into standard deviation of A into standard deviation of B. That is the formula of covariance between A and B. I believe everyone knows this already. Okay, fine. So you got the covariance between A and B. Now, what is the standard deviation of A is 0.25. So the variance of A, that is equal to 0.0625, 25 square, 625. Okay, so 25 square, 625. Now variance standard deviation of B is 0.28. Then the variance of B is equal to 28 square, 784. Clear everyone? 28 square, 784. Clear everyone? So you got the standard deviation of A, you got the standard deviation of B that is given. I do the square, get the variance of A, I'll get the variance of B. So what do you mean a minimum risk portfolio? You have to find the weight of A, you have to find the weight of B, you have to find the weight of B. Okay, you have to find the weight of A, you have to find the weight of B. That weight of A and B, when I'll put into this formula, that weight, when I'll put into this formula, when I'll put into this formula, when I'll put into this formula, I should get the minimum variance. I should get the minimum variance. When I'll put them into this formula, I should get the minimum value. You change the weight, you make it anything. You can make 0.9, 0.1, 0.85, 0.15, 0.75, 0.25. You change the weight in any way by using trial and error method. Ultimately, the risk on the portfolio should be minimum. So either you can do by trial and error method like that way, either you can apply trial and error method like that way, or you can apply the formula. So the weight, so the weight to get the minimum risk, the way to get the minimum, the way to get the minimum risk, if you apply the formula. So, so the way to apply the minimum risk. So if you apply the formula, so the formula is the formula of weight of A is equal to variance of B minus covariance between A and B divided by variance of A plus variance of B minus 2 times of covariance between A and B. Okay, so the weight of A, so the variance of B is 0.0784, 28 plus 0.0784 minus covariance between A and B. Covariance between A and B is 0.035, that is 0.035, that is 0.035 divided by 0.0784 plus what is the variance of B? I think 25% square, that is 0.0625 minus 2 times of covariance between A and B. So the weight of A, that is equal to, then this is equal to 0.0784 minus 0.035, that is 0.0434 divided by 0.0784 plus 0.0625 plus 0.1409 minus, this is 2 into 0.035, that is 0.07. So this is equal to 0.0434 divided by 0.1409 minus 0.07, that is 0.0709. So the weight of A is equal to, weight of A is equal to 0.6121. This is the weight of A. So you'll get the weight of A. This is the weight of A. So the weight of B will be equal to 1 minus 0.6121. That is 1 minus 0.6121. That is 0.3878. If you put this much weight of A and B into the portfolio, you will get the minimum risk for the portfolio. This is what you have to do. So the same question, so same question came in 2018 January also. The same question came in 2018 July also. So in when this came in January, it came for 6 marks. When it came in July, it came for 2 marks. Clear everyone? Anyone have any doubt? So we have discussed two problems till now. Anyone have any doubt? So I hope you understood the logic of minimum variance portfolio. So I'm not going into the mathematical part of how that formula is derived. What is important here is to understand that instead of using trial and error method, we can use the formula. By using the formula, we'll get the weight of 1 and 2 at which we get the minimum risk on the portfolio. This is very important for all university exams wherever the questions of portfolio management gonna come. So guys, make sure you watch this video. If you have any doubt to understand simple formula is that use that formula and you'll get the answer very easily. So with that intention, I'll wind up the class. So we'll let end this class. Thank you everyone. God bless you. Bye.